The next section of Unit 2 discusses binomial probability, expected value, and expected profit. Binomial probability is an event with two outcomes. Examples of those type of events: flipping a coin, trying to hit some kind of target. You're either going to hit or miss. Trying to shoot maybe a basketball, you either make the shot or miss the shot. And then Pascal's Triangle is a very good resource in order to help you calculate and determine probabilities, determine the number of outcomes for each different type of event. We're going to go through Pascal's Triangle here in just a second. Pascal's Triangle looks something like this. This is 6-7 rows of Pascal's Triangle, and this is an infinite pattern. You can go as far, create as many rows as you possibly need. We're not typically going to need much more than this. However, the principles here are what I want to show. First thing that you want to do is identify the number of events. This row right here identifies the number of events. So if you're taking 2 shots, you're going to use this row of Pascal's Triangle because here's where the number 2 is in this diagonal of the triangle. And then the total number of outcomes is the total of each row. So if you add up the entries of each row based on the number of events, you have how many outcomes they are. And then each position in the row of that triangle tells you the numerator of the probability divided by the number of outcomes for each and every different type of outcome. So let's take this row right here. If you take 4 shots of a basketball, the different outcomes are going to be 4 makes, 3 makes, 2 makes, 1 make, 0 makes. And everything on here has to do with the outcome of making. If you're taking 4 shots, the best you can do is make 4. And then each one after this has to do with the number of makes versus the number of misses. 3 makes, 1 miss, 2 makes, 2 misses, 1 make, 3 misses, 0 makes, 4 misses. Okay, so you don't have to talk about each number in that row in terms of both outcomes. All you need is 1, because in binomial probability, there's only 1 or 2 possibilities that each outcome could be. So 4 makes, what's the probability that you make the shot 4 times? Well, the very first entry is the numerator out of the total possible, which is 16. 4 for the probability of 3 makes is 4 out of 16, which we know simplifies down to 1/4. But notice this right here is the answer to this probability question before it's simplified, and it comes straight from Pascal's Triangle. 1, 4, 6, 4, 1. Each one of these represents the numerator for each probability of the 4 different shots you take. The next topic here is expected value. We have rules of a game that say you must hit a baseball into a fair zone for it to count, and you're going to get a total of 5 swings. The prize is offered. You get a large prize if all 5 swings result in a baseball going into the fair zone. Medium prize if 3 or 4 of those hits are successful. A small prize if 1 or 2 of those hits is successful. Now this is binomial probability because whenever you hit the baseball, it's either going to go fair or foul. So there's only 2 possible outcomes of a single event. Therefore, we can use Pascal's Triangle. And if you remember Pascal's Triangle, the row that we're going to use is the one where 5 is the second digit of that row. So I believe it goes 1, 5, 10, 10, 5, and 1. First thing we want to do whenever we calculate the probabilities is that we want to figure out our total, and this total here is 32. 6, 16, 26, 32. And then we need to figure out the probabilities of each and every possible outcome. So if we have 5 fair zone So 5 makes, 4 makes, 3 makes, 2 makes, 1 make, and 0 makes. Gives us the numerator of each fraction in the probability of each potential outcome for a single player. And so then we have the probability of 5 makes is 1 out of 32. The probability of 4 makes is 5 out of 32. 3 makes is 3 out of 32. And if you notice, binomial probability, half of the outcomes are identical to their exact opposite halves. Explaining that a little bit further, 5 makes is the best you can possibly do. The exact opposite is the worst you could possibly do. 0 makes. And think about that. 5 makes, 0 misses. 0 misses, or 0 makes, and then 5 misses is exactly opposite. 4 makes, 1 miss is exactly opposite of 1 make, 4 misses. 3 makes, 2 misses, 2 makes, 3 misses. These are exactly opposite outcomes, so they have the exact same probabilities. Now, what we need to figure out is how many large prizes, how many small prizes, how many medium prizes am I going to give out? All right, so here, if 200 people play the game, we can calculate the expected value of how many large, medium, and small prizes we're going to give away. And of course, again, this is all theoretical because we don't have any actual statistics. So the rules governing a large prize were 5 successful hits. So that is, the probability was 1 over 32. And that means 1 out of every 32 people will successfully get a large prize. So we have to then multiply that by 200, which will give us the expected value of how many large prizes me, as the carnival game operator, will give away. For the medium prize, it's either 3 or 4 hits. Well, the 3 hits was 10 out of 32, and the 4 hits was 5 out of 32. So when you add those, you get 15 out of 32, and then you have to multiply that by 200, because 15 out of every 32 people will get a medium prize, times 200 will tell us how many out of 200 we're going to need to give away. And then small is 1 hit or 2 hits. 2 hits was 10 out of 32. 1 hit was 5 out of 32. Again, this looks like 15 out of 32 times 200 will give us the expected value of how many small prizes we need to give away. Now we have expected profit. Expected profit is based on how many people play, how much each person paid to play, and then how much money we're going to give away based on these prizes. So if 200 people play and the game costs $3, that means our revenue is 200 times 3, which is $600. That means we make $600 before paying out any prizes. From the previous slide, we had the probability of 5 out of 32 times 200 people. That is actually 31 large prizes that we would give away. And each of those prizes costs $10. So we have $310 that we're giving away in large prizes. The medium prize was 15 over 32 times 200. That actually worked out to be 93.75. So we're going to round up to 94. Each one of those costs $2, so this is $188 that it costs to give away the medium prizes to 200 people. And then the small prizes, well, the small prize had the same probability as the medium prize, therefore the same number of people will get a small prize, and we have to multiply that by 0.25, and that's going to give us $23.50. Now each one of these is a negative because we're subtracting how much we give away. We're subtracting our expected value from our revenue, which is going to give us our expected profit. So if we take 600 minus 310 minus 188 minus $23.50, we are going to get 600 minus 521.50 is going to give us $78.50 for profit. Now, some of the discussions you can have with your students are, is this enough profit for 200 people that play? What should I do in order to increase my profit? And that is binomial probability, expected value, and expected profit.